The head count should match. If it does not, the entire class should be absent. It's quite fair, right? So that there is no chance to have the proxy. You won't do it, I know that. Nice guys. So please circulate like this, U-type, okay? Come like this. I don't know why it's so behind this chair. This is like that only. Okay, it should be actually aligned properly. Yeah. So can you please raise your hand toward the index? Very good numbers. Okay, and who are the PhDs and MS? Okay, I think almost like 50-50. That is great. This course is of 4 credit. Each credit is actually 50 minutes in the one lecture. We have 4 lectures. Monday it is 10 to 11. Am I correct? Yes. Tuesday is 9 to 10. Am I correct? And then Wednesday 8 to 9. And then Friday 12 to 1. Okay, what I will do is a good news for you guys, a little bit bad news. Wednesday 8 to 9 o'clock, today I am taking, but generally I don't prefer you to come at morning 8 o'clock, so that at least one day you can have more sleep. Is that okay? Okay, but I have to compensate the Wednesday class. So what I do, each Friday I take 1.5 hour class, then it's equal to 1:30. And that time, lot of coverage will be there. Any doubts, anything, each Friday I cover because I 1.5 hours span, I can cover quite a lot, and there is a time. So Monday, Tuesday class will be generally a bit fast because I have only 50 minutes, so I have to cover quite a lot. But Friday's class actually it will be quite comprehensive. I will go at my own pace and I can cover a lot and I have more time, 1.5 hours. So our class timing will be from next week onwards. Monday 10 to 11 usual. Tuesday 9 to 10 usual, and Friday is 12 to 1:30. Is that okay? Any objection? Okay. So Wednesday no, unless any emergency. That means I'm missing class on 15th of August and 29th of August, for example. These are all Fridays and they're holidays. So those Fridays I'll be missing two classes. So in that case I have to compensate. So that week I think we don't have to come on Wednesday morning 8 o'clock. What I will actually try to do, if any afternoon slot is free, so we can actually take 1 hour class. So generally afternoon 4:45 slot is generally free. So in that case we should actually, now who is the class here? This year has been decided from MTech side or BG side? Okay. You are the class here? MTech, okay, fine. What's your name? Bharat, okay. So just sit down. What you actually do that, what I actually expect? Either Monday or Wednesday or Thursday slot, Friday's afternoon slot, if you can make it free for me. So in this case, going to be having a lot of holidays, I need to compensate one class. I can actually do that. You are MTech or MS or PhD, sir? MTech. Why you are coming only with this, no books, nothing? Just came for fun. If you do that, the problem is that you don't know what is actually happening. You are going applying for some job or anything? Applying for job. I don't know. Okay. But generally I don't allow to enter the class late. Okay, so please be on time, is better. Because I get distracted when I'm teaching. So class timing is okay, right? So your CR's duty will be that to make one spot free. That Wednesday or Thursday afternoon, 4:45. In case I need any extra class emergency basis, I am missing the class on Friday, I will go for that slot. Is that okay? Yeah. And next will come the grading policy. Quiz 1, 20 marks. Quiz 2, 20 marks. Attendance, 10 marks coming. And N7, 50 marks. So now you can see that if you attend the class, 10 marks is given to you. Right? That's a good thing. Okay? And we have the grades S, A, B, C, D, E. You know that. We have got this type of grading policy, 6 scale. S, A, B, C, D, E. Generally E grade I put it 20 marks, cut up. That means it's easy to pass in this course. But of course for MSPS you have to get minimum C, right? So, but for MTech you can go at least 3 and no problem. Unless you are satisfied in other categories. So if it is 20, I will just tell you how easy to pass. If you attend the class, you get 10 out of 10. That means I demand 95% above attendance, not all the classes. You have to calculate, but things I always encourage you to come to the class, because if you don't come, you miss something. But if you want to do good grade, do good score in the exam, definitely you have to come to the class, and in that case you can follow and you can do much better. So if you attend the class, you get 10. Quiz 1, quiz 2, if you just get out of 22, 3 marks, exam was 10 plus 6, 16. And 50 out of 50, if you get only 4 marks, you get 20 right now. So passing in this course is not that difficult, it seems. And generally there is no backlog in my course unless you try for that. I always tell that incident what I actually faced when I was teaching BTech long back. One BTech kid actually told me that he wanted to fail in my course. I said, you cannot, because I don't want to fail you, because at BTech E grade is allowed. He said, I will not get E grade. What that guy did, the first quiz I think somehow he could get 1 or 2, second quiz also he got 1 or 2, and he was thinking that he will be able to pass. At the 8th semester he came, he nicely wrote the questions, not the answers, and I had to give him 0 because I cannot give marks on writing questions, and he failed the course. So that is the way you can actually fail in this course. Is that clear? So if you study well, definitely I am always, when I grade the quiz, you ask your seniors, in the first bench your 3 MTech seniors are actually there, and one of my senior PhD students is there, and you can talk to them, they will tell you much better how the grading process and how to do the stuff. Now the thing is that, what is the textbook? So in this course, the course syllabus is very vast. You have analytical mathematics, you have analytical math, you have numerical. Okay? Analytical math, what we will cover? I'll come in details. Vector space and functional space. Numerical techniques. Not a single book actually would address all analytical numerical part. Analytical part, book by Professor Pushpavana, Mathematical Methods in Chemical Engineering. That's a textbook for the analytical part. Okay? The numerical part, varieties of books. Now the thing is, when you do analytical numerical, I do not follow any specific book, and I am teaching this course for so many years. I do research on mathematical aspect. Based on my research, I put my experience, and I will just share my experience. So I think if you follow my class notes and do the class assignments religiously, I think you will be very much better off for scoring even a S grade. You don't need to have any books to be consulted. Okay. All I am saying that you need to understand the thing, the content, what I am teaching in the class. Okay. So this is the policy. Any doubts, any questions, you can actually always ask me. I would be very happy to share with you. Okay. Now the thing is, getting back to the subject, why we need this subject? Why do we need practical methods in chemical engineering? Any ideas from your side? Just like that doing some mathematics in chemical engineering, you are doing, or is it required? Is it necessary? Any ideas from your side? I would sincerely appreciate. Why we need mathematical methods? Or do we need at all this course? What is the use? As a chemical engineer, can you find the use of this course? Any ideas from your side? Yes, madam, please. Sit down and talk. Yeah, no need to stand. Yeah. Various problems we need to do mathematics. Then computer problem is much difficult. I don't understand much computers. Control problems. Okay. Okay. So one good aspect you are saying that when you do process control. So thing is that we also call ourselves as process engineers. So before getting into process engineering, let me share how this chemical engineering comes actually in picture. So, chemical engineering actually came, is a very recent subject, I think late 18th century, maybe 1880, or maybe before that, I don't know, I don't remember the actual year. The chemical engineering has been started. So, in lab, if you look at, we prepare sulfuric acid, we prepare different compounds in the lab. And lab scale is only in the test tube scale, not in the bigger scale. So, test tube scales, chemists are successful. So, but in the daily life, what actually happens, people are trying to use a lot of chemicals for the food substances, or packaging, or many of the uses, soap factory, petroleum and all. You need to have tons and tons and even a few metric tons or whatever to deliver the society. The society needs so much of tons, not the material. Okay? Chemistry will be failure. Chemists, what they can do? They can actually have a test tube, Bunsen burner. How much? Some few milliliter. Okay, we can deliver. Not even tons, not even kgs, not even grams. Society cannot run with the milliliter and gram production. We have high demand. Daily, if you go there, how many soaps have been sold? I don't know. Many shops, for example, we are selling so this much soaps, and soap has a lot of components. So, for example, one of the industries are saying that 100 tons per day they want to prepare sulfuric acid. You need sulfuric acid for different purposes. Chemists say I cannot do that. 100 tons, how many test tubes? Impossible. You cannot do that. So, what actually? So they have the calculation for say 10 cc of the sulfuric acid. I know I want the components. Then maybe sulfur this much, maybe this much water. So chemical engineering came up with something called scale up. They will say if you have for 10 cc this much sulfuric acid for 100 tons, I need to have some few kgs. Could be 100 kg of sulfur. I have seen sulfur, yellow color, it's a big size, they're dumped in the industry. And if you go there, the smell is very bad. But you have to run the society, the industry. So you have to get the smell. So chemical engineering, one of the problem is, if you have some problem with the smelling, this is not a good thing. But there are good aspects in chemical engineering. So, chemical engineering subject has called something called scale up. With that, they have got the estimate, few kgs we want. Few kgs we cannot accommodate here. Okay? So for few kgs, you need to have big bucket or big container. Okay? So you can dump few kgs here. Okay? And then, what actually happens? You put the sulfur blocks. You need to put water. They have to be properly mixed. Otherwise, some portion reaction will be occurring. Some portion only sulfur is the water cannot reach. Reaction cannot occur. So you have to have stirring in that so you can mix it up. This kind of big size you cannot put. You have to make it different kind of small size. You cannot use hammer. So there are something called crusher, grinder. First subject has been discovered, mechanical operation. Mechanical operation subject has been discovered. They found that we need to do a lot of mechanical operation to start the process. Okay, so we have crushing, grinding, size separation. Sometimes we have a lot of contaminants in sulfur. We need to remove the contaminant, filtration. So for our need, we have first subject, mechanical operation. Okay. Previous to that, we have stoichiometry because you need to understand the stoichiometry for the reaction. So stoichiometry subject has been borrowed from the chemist to understand, so that you already know that that's called process calculation. That is nothing but applied stoichiometry. You can say that is like chemistry. But a lot of chemical engineering touches that, that I'm not going to discuss much details. So with crushing grinding, you can actually have small sulfur size. You can have small pieces, and even that you need to have more reaction. You need to have startup. Okay. Even the starting operation, this is also a mechanical operation subject. We have seen that the starting things we put sometimes baffle. Then we might have heard something called Prout number. All those things come in mechanical operation. If you look at Macap-Smith's book, all those things have been discussed nicely. Then we have to transport water. Do you want to put bucket of water? The human beings will be tired. The people who are giving manual labors, they will be very much tired. So what can be done? A container will be there. You have full of liquid or water. You need to have this will react. So it will be connected. So point is, it is not a straight pipe. It could be having kind of bait. It could be because reactor could be somewhere. Sometimes some processing will be there. You might remember process calculation, something called flowchart. Flowchart will give you idea. The reactors, filtration, whatever. So you need to have the proper sulfur. Do crushing grinding. Do filtration. Different units will be in different places. Because one place you cannot have. The industry will not be like a circular thing. There are kind of, there could be some buildings and all those things. Layout will be there. And for a chemical industry, civil engineer's role is very important. So civil will actually give the plan. So when the water is actually, or fluid is flowing, we need to know about the pipe diameter, pipe structure. You need to know the valve size, what the valve size, valve capacity. So we need to have the subject called fluid mechanics. Okay? So that's the way fluid mechanics subject was introduced in chemical engineering. And when you actually supply the fluid, you need to maintain the particular temperature. You need to see that, and the reactions actually occur at temperature and pressure. Okay? So the temperature pressure is different, the reaction speed could be fast, could be slow. You might have seen all those things in chemical reaction engineering. So you need to have a subject called heat transfer. And the reactor, it is not like the reaction what actually my chemist friends will do. There could be different aspects. With the reactor design, how fast the reactions can occur. And how the fast reactions can occur, you have to see the residence time. How much residence time means how much of the reactant and product reactants are actually in the contact. If there is more in contact, more reaction. And also reactions could be very fast. It could be the flow type reactor or the batch reactor. So this, when you talk about the flow type reactor, batch reactor, chemists don't know those. So we designed a new subject called chemical reaction engineering. So these are the ways different, and same way we have mass transfer. When we talk about the, for example, when we have the, for example, wet sulfur, you need to have dry sulfur, you need to have humidification, you need to actually have the moisture content could be removed. So in that case, once we talk about the components, different multi-components or different materials which are actually removed, then in that case we have the mass transfer. So chemical engineering specialty, we have mass transfer, chemical reaction engineering. These are the subjects which are especially for the chemical engineering. Fluid mechanics heat transfer have been borrowed from mechanical engineers. Now when this operation is actually coming, some of the time, sometimes you can do the scale up kind of calculation, you can get the answer. Sometimes in a process, fluid mechanics, heat transfer, chemical reaction, all going on together. And it is very difficult to do the hand calculation. So in that case, we need to define the entire process. Define the process. Simplification. Simplified way. You got so much things going on. You discuss, okay, at this type of pressure, reaction temperature, I am having the water and then sometimes sulfur content, they are all coming. They are actually, another thing is there, here mixing operation going on, and then while mixing, how much temperature will be raised, we don't know. This could be two different temperatures. So, in that case, we need to estimate the temperature. We need to estimate how much could be the fluid velocity to be the reactor. And that fluid velocity you cannot calculate just like that. We need to have a procedure. So, when calculation comes, and these calculations are very important because if you deliver 100 tons per day, if you don't calculate properly, the industry will not run. And you should not, lose out your money on the industry. So, when you talk about the definition of process in a simplified way, and that is the answer, which is the mathematical methods. What it will do? When we have all the subjects actually born in chemical engineering, we want to estimate how much, talking about the mass, talking about the heat content, talking about the fluid velocity. In that case, we have to define, we have to quantify the calculation, and those calculations, when you talk about definition of process, first thing comes actually balance equation. First thing comes balance equation. So we have mass balance, momentum balance, heat balance, we have species balance. Mass balance is continuity equation, you might have heard. Momentum balance, you have heard or you have seen Navier-Stokes equation. Heat balance, we have seen energy balance equations, and we have species balance for mass constant. Okay. So this is the way the balance equations actually. You are too late, sir. Not. I'm sorry. I can't have you. Next class. See you next class. Thank you. Okay. See you next class. Okay. So mass, momentum, heat, and species. And when you write the balance equation, what kind of equations you get? There are two things. I have a reactor. I am starting it very fast. That means each point, the temperature, the species concentrations, they are all same because I am starting. There is no gradient. There is no change from point to. That's what starting means. I am making uniform. That's the rule of start. So if you have well-mixed system, then you get algebraic system of equation. What is the balance equation? When we talk about balance, the balance will be very simple. Accumulation equals to in minus out. That's it. It will be valid for mass accumulation, heat accumulation, momentum accumulation, species accumulation. This is the basic. This is a simple equation. It looks like algebraic. How much quantity? I am putting in a container some mass. After reaction, I want to see how much mass is remaining. If reaction occurs, a new kind of species will be born. Then I will talk about the species balance. For example, if you have carbon dioxide formation, C and O2, how much carbon balance, how much oxygen balance, how much carbon dioxide balance, how much total balance. So, algebraic equation comes if you have open well-mixed system. But when you have, for example, catalyst pellet, reaction occurs here because of catalyst only. It's like a pore diffusion problem. Things actually go here, gaseous species, once it is in contact, reaction will occur and the product will come out in the gaseous. So, if you look at the species concentration will differ from point to point. Reactant concentration is almost zero here because reactions are already occurring. Product concentration is very high, and here reactant concentration is very high. Product concentration is low because it has to travel so much. So and things are changing with time. So when things are changing with time, like this kind of case, things are changing with space, you cannot have algebraic equation. Okay? Things changing with time. How will you write? Say for example, some quantity called C dc. So differential concept has to be there in chemical engineering. When things will change with space, it is dc dx. When C is changing with time and x, we have dou C dou t. We have dou C dou x. That means partial differentiation. So chemical engineering has algebraic system, differential system, and that we have ordinary differential system and partial differential system because of this type of situation. And this kind of system has to be there in the accumulation. In that case, accumulation equation will be rate of accumulation equals to rate in minus rate out. If reaction occurs, then it will be rate of accumulation equal to rate in minus rate out plus generation minus destruction. That is the way the overall. So now we can see why we need mathematics in chemical engineering. This is the picture. So we need to quantify how the heat, how much heat we require, how much mass is coming. These questions will come from a layman. Operator in the chemical industry will ask two questions. So how much heat we have to give in the feed so that our reactions will be occurring nicely. How much feed we need, how much sulfur we need, how much fluid we need to get this much product. You cannot calculate just like that. If this type of process, catalyst based reaction or this kind of reaction, if there are so many components involved, it is not that easy by doing calculator. You have to have the balance equation, and the balance equation could be algebraic. When you talk about the balance equation, there is a question of mathematics, and when there is a balance, there could be well-mean system, there could be catalytic system, and we have the algebraic system and the differential system. Any questions? That's why the mathematical methods in chemical engineering. And next, when you have the process, what actually happens? The heat input is being changed in the system. For example, there could be, because it is difficult to have the same heat input, there could be problem in the system, or there could be the heat source may not be available, or there could be some other restrictions. So if you perturb the heat system in the thing, how much perturbation will be there in the reaction of the product? And there is some subject has been born called process control. If you perturb the some system parameter, or if you change the fluid flow, how the reaction speed will be changed with the fluid flow? Will it be linear? It could be quadratic. It could be some complicated function. What is that function? Something called transfer function. We actually talk about. So that is the way process control plays a lead role, and without mathematics, process control cannot be there. So process control is process control is basically very important for chemical industries because so many parameters are there: heat flow, fluid flow, and so much stuff. And any of the parameters will change, it will affect the product output, product quality. So in that case, we have to estimate if it is changing so much, how much is the change in the product quality, and then you can decide by doing a mathematical analysis that okay, this much heat input cannot be changed. If we change this much, it will severely affect the heat and fluid. Any questions? Any ideas from your side? Have you understood why we need mathematical methods? There are so much aspects, right? Without that, today's chemical engineering is not possible of so much complications and other stuff. In fact, mathematical methods in chemical engineering, this subject is very new, I can tell you. When I did my bachelor's, that time we were slightly having that course, and the book actually I used to follow during my bachelor's days. The books had the subject was applied mathematics for chemical engineers, and the authors are Mikles, Sherwood, and Reed. Have you heard that book, Mikles, Sherwood, and Reed? Yes or no? No. So that is the seed. Imagine that long back, almost more than 20 years back, I finished my BTech, and my BTech 4th year, that was a core course. Applied Mathematics and Chemical Engineers, and the two books were followed. Nicholas Sherwood and Reed. Another book was Jensen Jeffrey. Have you heard? No. Jensen and Jeffrey. So these two books actually I followed and Applied Mathematics for Chemistry. So they are actually have been introduced. And that was the inspiration for me, and that I got so much inspired. And some of the equations, when you have the differential equation, is sometimes differential equation is so complicated you cannot solve analytically. And in that case, numerical methods have been taken from the mathematicians, and that's what the subject also we have, numerical methods or numerical techniques, and that subject also I have studied in my bachelor's days. And that gave me, when I see, and when you go to the mathematical world, you see plethora of research or plethora of opportunities in chemical engineering. Because there are two aspects in chemical engineering. One is the experimental aspect and one is the mathematical aspect. I rather people will say modeling and simulation. So it's, sometimes we ask actually why we need mathematical kind of research, because you know, these are the processes involve a lot of physics, okay, and so physics does play a critical role in mathematical modeling or this kind of research. So if you have a critical process and how to experiment, for example, what should be the parameters to conduct experiment? Some people may say that okay, you can conduct experiments, you can have different set of parameters, change heating rate, change the temperature and all those things. In that case, you're wasting so much of time to see the optimal process. Maybe it could take years, it could take months, it could be some days, but you need to have a lot of arbitrary experiments. Of course, we don't know what are the parameters. We have to have the different set of parameters to find the optimal process. But mathematics plays a critical role with the mathematical equations. If you set up your optimization procedure, you know, everything is there, then within even few days you can get a result which could be the result of the experiments of few years. So that's what the mathematical modeling actually is so powerful. It's not that easy though. When you talk about mathematics, you need to really compete with the physicists and mathematicians. But there are a lot of challenges, there are a lot of scopes on research in the chemical engineering. Before getting into the subject, since I was talking about the mathematical research, I first talk about what kind of research actually I do, and then I will slowly get into the subject. So, since you can see that I am teaching a course on mathematical methods, my research has to be mathematical. So, I did experiment, or I do experiment, but thing is that I have seen the mathematical world so critically in chemical engineering, and I see there are a lot of fun and a lot of scopes in chemical engineering. If you know mathematics, you can actually get into any of the complicated process of chemical engineering and you can crack it. Okay, so what actually I do, two aspects. One is the called microwave heating. So that is real fun actually. I have started my journey of microwave heating during my PhD work when I did my PhD. And we have seen the microwave oven, right? And we can put the food material or any materials here. And we have seen your home, right? Household. And if you switch on, it will start rotating, right? Microwave will start rotating. So that plate will start rotating. So, and thing is that this food will be getting heated. How it will get heated? What's the equation? Do you have any idea? You have done it now. What's the equation? When if you put a material in the microwave oven, radius, what's the type of equation? Pardon? Do you know the actual mechanism when you put some material in microwave? On what mechanism the material is getting heated? Pardon? Yes. Anybody can volunteer, I will appreciate. Because we are using every day. We have seen it, right? I think everybody's home, I think we have seen, right? Microwave will be there, at least one. Radiations. What radiations? Where from? Where from radiations will come? See, okay, now what's the procedure? If you look at, there is something is there, some kind of mesh kind of thing that is called as magnetron. Okay? When you put the sample for 5 minutes or 10 minutes, you are saying radiation. But this is not hot. If it is very hot, then only you can get radiation from there. It is a room temperature. Once you put the microwave, then even a small beaker of water, it will be heated in 1 minute. In my lab, actually I take sometimes tea, in the evening time. I have a cup of water. I put in the microwave. Within 1.2 minutes, I have got very hot water. But it was not hot. How radiation is not? You are saying radiation, so that is not correct. How the heating is there? If it is very hot, radiation means I am getting heat from sun. That is called radiation, right? Sun is very hot. If you go in the daytime, like 12 o'clock, lunchtime, in April or May, you will feel very hot. Why? Because of the sun radiation. Is this kind of thing there? Is it always hot? If it is hot, then you can feel it. When the microwave is open, it is very hot. It is not like room temperature. Switch it on, within 1 minute your water is boiled. How is it possible? How is it possible? Any idea? It is not hot. Is something coming from here? Of course something is coming which you cannot see. What is that? It is not radiation though. You said radiation is wrong. It is not hot, but something is coming. What is that? Somebody please, you are participating but I am not able to participate with you. Yes. Something is coming. Yes. Magnetic field, who said? Yes, very correct. It is not magnetic field, electric and magnetic field together. That is called electromagnetic wave. So, when you switch it on, the switch will be there, and if you switch it on, then wave will start propagating. That is called electromagnetic wave. Material is there, good material. Each material has dipole, plus and minus. Plus and minus. This dipole generally when you don't have any electromagnetic field and magnetic field combination, electromagnetic field, electromagnetic wave, this will be all random fashion. That means plus will be with minus or minus will be plus. So overall polarization is zero. When microwave is passed in this material, what actually happens? This dipole will start orienting towards the electromagnetic field. That means all dipoles will be ordered. Okay? But what actually happens? This is wave. That means this is going like this. So direction of wave is changing. You can see that. It's a wave, sinusoidal wave, or something very complicated wave. So dipole also start orienting. Now it is this direction. After that is this direction. It is this direction. So dipoles will start moving. While moving, what actually happens? So if you just do that, you can see that if it is moving, some friction will be occurring. So this friction also occurs within this dipole. It will generate heat. And it is happening throughout the domain. So what actually happens that within the system, something is actually happening. Each point is generating heat based on this friction. So physics is very interesting. So if you talk about the energy balance equation, it will be rate of accumulation, rate of heat in minus rate of heat out plus generation time. For this kind of heating process. And you know that in heat transfer, that is the partial differential whatever. But that is the way if you solve it. But a generation term, if you want to talk about, it is very, very complicated, not just straightforward. How much is being generated? You don't know. What it will be depending on? Electric field or magnetic field, right? So now, how the equation for electric field, do you have any idea? If electric field goes, how it is generating heat? What is the equation? So in chemical engineering, in our country, I am the only person working on this, and people are doing experiments. There are a lot of experiments going on, but experimentalists don't have the equation how the heating actually occurs. We talk about equation, we apply the equation, you see that how the heating process goes. I will tell you why it is interesting. You have a bigger sample, you have a smaller sample. Microwave. If you put in our usual gas oven, it will heat faster than this because it requires less amount of heat to heat. Correct? careful. No, you cook also. You cut in the small piece, you cook is very fast. If you have bigger thing, it will take longer time. But in microwave oven, we found for some specific sample dimension, bigger sample is heated faster than the smaller sample. If you ask me the answer, I will actually tell the layman's language. See, when in this kind of square domain, the waves are propagating, it is getting heated here, it will generate another reflection wave. So what actually happens? You will get standing wave pattern. We can see there is some construction interference and destructive interference. We have seen in that +2 stationary wave formation. With that, it is possible to find that there are a lot of constructive interference for this case, and a lot of constructive interference means a lot of heat generation. That's why the heating rate was much faster than this. So that's why people use microwave. There are so much counterintuitive effect. Those kind of things, with sample dimension, on what basis all this counterintuitive phenomena occurs, how the constructive interference is, what is happening within the microwave when you see. You can conduct experiment, you can see the result, but what is happening inside, mathematics will give the answer. And that's what I am looking into inside what is actually happening. So this topic has tremendous impact on heating of food samples, heating of tissues, and most recently on the cancer treatment. So what actually people do that when we have, for example, is a body and there is a place where the cell or tissue is growing. So what they do, they put injection. And small syringe is there, okay, and microwave is passed. So what actually happens, for example, you need to destroy this growing cell. So it will be sent there, and this will be heated by microwave, and this will propagate heat at this point. And sometimes what actually happens that you put a shield here so that you don't damage the other material. So this is called hyperthermia treatment in cancer. So these are the kind of research actually we are doing in microwave heating, and this project is open for the intakes. So there are two kinds of projects I am doing. One for the regular publication based. Basically, whatever research you have to do, you have to publish papers. Other research has no fun. So this is the time you will be getting the test of publications. If you publish, your work is archived, and what actually happens that your paper is in good journal, then when other people will refer, your work will be recognized, and that is the way we get it. And why you publish? If you don't, somebody else will publish your work, and then you won't get credit. Somebody else will take your idea without knowing or with knowing and refer the thing. So that is the way all we know the scientists, Archimedes, even Reynolds, all these people publish their work. Otherwise, Reynolds number wouldn't have known. So publication is the only way to dissemination of the knowledge. Another work actually we do the convection kind of work. Natural or mixed convection. What actually happens, we have different shape of the cavities, or we have distributed patterns. For example, we have heat source here, we have heat source here, like semiconductors or the computer chips, different kind of chips are there. We have the fan here inside. Okay, how the chips will be oriented so that your heat generation is minimized. So in that case, when you talk about thermal management, so those type of things, if you see the physics means you have to solve the Navier-Stokes equation. That is called as full-blown CFD. Now the thing is that this could be irregular shape, this kind of thing. And if you talk about the packages available in the market, they are actually fluents and CFX and irregular shapes. It is very difficult sometimes to quantify, and in that case we have got our in-house finite element based computations, FEM based CFD. We work on finite element method, and that I can tell you that in chemical engineering in our country, in India, I am the only person working on finite element method. So we don't actually use any commercial CFD package. We have our own packages, and we solve set of problems. You can talk to my MTech students; they will actually explain much better. So natural mixed convection, I have plenty of projects. Ongoing projects, and my MTech students actually Santosh and Maniratnam actually they are working on the natural gas foundation. I think they have cracked one problem, and both of them actually now writing a paper within a couple of months. And Akshay is working on the microwave heating. Is sitting here, so in that case you can have a rough idea when you talk to them. So that's my research, and now you can see that how mathematics is connected towards research, towards development, and all these problems. Not many chemical engineers actually do that, and mostly, if some of you actually could not get mechanical engineering, some of them was actually, some of you guys actually must have been upset. Oh, I wanted to do some mechanical engineering. A lot of fun is there, and of course I can tell the chemical engineering is not the chemistry. It is having a lot of mathematics. If you want to do mechanical engineering, I am the person. I am working mostly on the mechanical engineering aspects, and in fact, my PhD students and a lot of my students are working right now. The factory, the R&D sectors like Siemens and all the places where the mechanical engineers are already equipped. So you can see that how vast the chemical engineering is, how vast the mathematical methods and mathematical techniques which can lead you to the global academia, global industry, and global plethora of the applications. With that, I will stop my today's class, and next class is on Friday 12 to 1:30. Thanks for coming.